You've probably read articles in which researchers claim that their results were obtained through reliable and valid measurement instruments. But what does it actually mean when instruments are reliable and have a good measurement validity? By the end of this video clip, you will know. First, what do reliability and measurement validity have in common? Well, both relate to the quality of a measurement instrument. So, what determines the quality of a measurement instrument? When we use an instrument to measure a characteristic of a research unit, measurement errors are usually made. So, for example, when we use a weighing scale to measure the true weight of a person, we will probably make a mistake, even if it's a very small one. This measurement error gives us insight into the quality of the measurement instrument. Generally speaking, measurement error can be considered as the deviation between a research unit's observed score on a characteristic and its true score. Suppose for a moment that we have a person whose true weight is 70 kilograms. We measure this person's weight using a weighing scale. This weighing scale shows an observed weight of 80 kilograms. This means that we have a measurement error of 10 kilograms. Now, what can this measurement error tell us about the reliability and measurement validity of the weighing scale? Let's look at the differences between reliability and measurement validity. When we discuss the reliability of a measurement instrument, we ask ourselves the question, under equal conditions, to what extent does the instrument yield the same observed scores with repeated measurements? An unreliable measurement instrument will show extensive variation in observed scores and therefore will show a large random measurement error. When we discuss the measurement validity of a measurement instrument, we ask ourselves the question, to what extent does the measurement instrument actually measure what it is supposed to measure? In our example, this is the true weight of the person. An instrument with a poor measurement validity may show similar observed scores with repeated measurements. However, these measurements may have nothing to do with the true score. For example, if we use a measuring tape to measure a person's height as an estimate of his or her weight, we have a problem with the measurement validity. In this case, the measurements will underestimate a person's weight if the person is short and fat. It will overestimate a person's weight if the person is long and thin. So here the use of a measuring tape is obviously not a valid procedure for measuring a person's true weight. Now, of course, a weighing scale is supposed to measure a person's true weight. However, the measurement validity of a weighing scale may still be poor because of systematic measurement error. Let's look at an example. Suppose you ask a person with a true weight of 70 kilograms to stand on a weighing scale not once, but 10 times in a row. The results are in this table. Obviously, the true score of the person did not change. It was always 70 kilograms. However, the observed scores as measured by the weighing scale did change. Each time the weighing scale showed a different score, sometimes above the true score and sometimes below the true score. As a result, the measurement errors also varied around zero. As a matter of fact, if you would compute the average of the measurement errors, you would obtain a value of 0. This means that the measurement error in this example is completely random. There's no systematic error. Because the weighing scale does not show similar observed scores with repeated measurements, we can conclude that we have an unreliable weighing scale. Obviously, this is not what you want. So, let's buy a new weighing scale. Again, you ask the person with a true weight of 70 kilograms to stand on a new weighing scale 10 times in a row. As you can see, the results in this table are quite different. Without exception, the new weighing scale showed an observed score of 80 kilograms, which is always 10 kilograms above the true score. The lack of variability of measures means that we have a very reliable weighing scale. But obviously, this weighing scale has a very poor measurement validity. There's a systematic bias of 10 kilograms in the measurements. As a result, this weighing scale does not measure what it is supposed to measure, the true weight of this particular person. Again, this is not what you would like to see. Okay, let's buy a third weighing scale. Again, you follow the same procedure. If you look at the data for this scale, you see that the observed scores are pretty close to the true scores. There's some random measurement error, but it is only in the order of about 1% of the true weight. Even more importantly, there doesn't seem to be any systematic measurement error. So, here we finally have a reliable weighing scale with a good measurement validity. At this point, you may wonder, how about reliability and measurement validity in qualitative research? In qualitative research, the researcher is often part of the measurement instrument. For example, the researcher as an interviewer or participant observer who collects qualitative data in the form of naturally occurring talk. Also for such data, the same principles apply. Take, for example, a female researcher who interviews men about their attitude towards having a woman as a superior. Now, suppose some men actually dislike the idea of having a woman as a superior, but because the interviewer is a woman, they do not dare to speak their mind. So, when the interviewer asks these men repeatedly about their opinion on a topic, they tell her every time that they are happy to have a woman as a superior. In this situation, the interviewer and the question together form the measurement instrument. This measurement instrument is very reliable because every time it measures the same value. I'm happy to have a woman as a superior. However, obviously the instrument has a poor measurement validity. So to conclude, both reliability and measurement validity relate to the quality of our measurement instruments, or in other words, the extent to which the use of a particular instrument introduces measurement errors. A measurement instrument is reliable when it yields only minor variation in scores in the same person or object with repeated measurements. An instrument has a good measurement validity when it measures what it is supposed to measure and does so without introducing bias. So to obtain good quality data and solid results, measurement instruments need to be both reliable and valid. Thank you for watching.